Okay. So let's start with the one note only, okay? In that we will discuss each and every reaction.
Okay.
Okay. So one note is visible or not?
No.
No? Give me a second. Um, 1 minute. Just Is now?
Mm-hmm. Yeah.
Okay. Okay, great. Okay, so in this case, there is first reaction, this one, OH. OH is in acidic medium,
Mm-hmm.
H2SO4. Okay, so how we deal with this reaction? Okay, how we identify that the given compound is in acidic medium by the help of H2SO4. H2SO4 is a acid, so it donates some H positive. Yes or no?
Mm-hmm.
Great.
Yeah.
Then the lone pair of oxygen will gain this hydrogen.
Mm-hmm.
Hmm?
Yeah.
So after that, this will be converting into O, H, and H. And there is a positive charge on this one. Yes or no?
Yeah.
Hmm? Okay. After that this bond will break, okay? And
Mm-hmm.
dehydration will take place. What is the meaning of dehydration?
Dehydration, you're taking off water, right?
Yeah, water. So in this case, when water removed, then what will coming here? This one. Okay. So see, there is a bond in between carbon and carbon and oxygen. Yes or no? So the bond in
Mm-hmm.
between carbon and oxygen will breaks. Okay.
Mm-hmm.
So there is a positive charge will come. Do you understand
Mm-hmm.
how?
Yeah, because of the loss of water.
Because of the loss of water, yes. And there is a deficiency of valency for carbon also, no? Because there
Mm-hmm.
is one bond in carbon will break.
Yeah.
Yeah. So after this, the positive charge will come, and positive charge on carbon means,
That it's deficient.
yeah. And what sort of intermediate it will be?
Carbocation?
Yeah, carbocation. So in case of carbocation, what is the next step if we are having a carbocation intermediate?
Um, yeah. So there can be some rearrangement
Yes,
or
absolutely. Yes. So how we will generate that rearrangement? What sort of rearrangement possible here?
I think alkyl halide, right? Alkyl, not alkyl halide, I'm sorry, alkyl shift. I don't know what I'm saying.
Yeah, alkyl shift. So how the alkyl shift will proceed here?
Mm, one of the methyl groups
Yeah.
shift over.
So in this case, carbocation is 2 degree or 3 degree. It is 2 degree. After shifting,
Mm-hmm.
after this one alkyl shift,
Mm-hmm.
this will converting into this product. Yes or no? And now tell me, carbocation attain at which position? First, second, third, fourth, fifth, sixth. Which position carbocation will shifts?
The sixth one?
For sixth one?
Oh, so yeah,
Attempt.
yeah, yeah.
Are you
Or
sure?
I think so, yeah.
After see at first position and at sixth position, there is a like At first position there is two alkyl group, and at the sixth position there is a carbocation. Yes or no? Is there any problem over here? Hmm?
No.
Then 1 to alkyl shift will proceed. Okay, 1 to alkyl shift means that, let's suppose there is an alkyl group, that let's suppose a methyl is there. So methyl is also alkyl. So when the methyl shifts at the sixth position, let's see here at sixth position when alkyl shifts, so there is a deficiency of one bond over the first position now.
Mm-hmm.
So the carbocation shifts to first. Any doubt?
Oh, okay. Because there's already,
That's how like alkyl shift and methyl shift will proceed.
because you're breaking, there's two alkyl at carbon one, right? Or two methyl.
Yes.
Yeah,
Two methyl, yeah. Two methyl, or we also can say alkyl.
alkyl.
Yeah.
So which one do you choose to actually like shift?
Any one shift, because both of them are
Oh.
same, na. If there is a different groups are there, so in that case we'll choose that, let's suppose, is there, if there is uh 2 degree 2 degree alkyl group,
Mhm.
and is let's suppose there is a 3 degree. Okay, so we shift a group which stabilize less carbohydrate. Let's suppose this is the other group. Okay, so there is two possibility. If I shift 3 degree group, 3 degree shifts, and if there is a 2 degree shift will proceed. Okay, so in that case there is a carbocation. Okay,
Mhm.
now we will see that which group stabilize the carbocation more. So we prefer that particular group to live together with that carbon. Okay, so on the basis of stability of carbocation, we'll identify.
So the one that's, but bo aren't both of them on the same carbocation?
Both of them are carbocation, but there is a 2 degree carbon and there is a 3 degree carbon attached with the part. Just forget this part, okay? No issue.
Oh,
Because in this case, all the two methyls are same.
okay, okay.
Okay, so both the two methyls are same. So one of the methyl will shifts, and a carbocation attain that position from where the shift will proceed. Okay, so let's suppose from the first carbon, methyl group shifts. So the carbocation will shift to the first carbon. Okay, let's suppose if there is two methyl on the fifth position. Okay, not on the first position. So in that case, what will happen?
In the fifth position,
Mm-hmm.
the one closer will shift?
No, I'm just asking you that if
Oh,
there is two methyl group present on the fifth position.
two. It's either one is okay, right?
Hmm?
Either you can shift either methyl group.
Yeah, yes, let's suppose. Okay, so let's move to this mechanism only for now, because we need to complete these mechanisms. Okay, so 1 to alkyl shift will proceed. Then, in acidic medium, if there is a carbocation, so in that case, even mechanism will proceed. Even
Okay.
mechanism. Even mechanism means
Elimination.
elimination. Great. And elimination at which position, or what sort of eliminated product we get? A substituted, more substituted. Okay, substituted product we are getting. So in this case, this hydrogen, there is a hydrogen also now.
Mm-hmm.
So this hydrogen comes here, and there is a double bonded alkene will form, which is most substituted. This is the whole mechanism for this reaction.
Okay.
Okay, so do you have any doubt in this reaction, like how the whole reaction will
Mhm.
proceed?
Did we cover E1 and E2 or completely no, right?
No, we didn't.
Okay.
Yeah, for now we didn't cover, because the E1 and E2 will come in the reaction mechanism part for alcohol. Okay, and we didn't complete the whole part of alcohol up to now. So what,
Yeah.
what is E1 and what is E2? Let's see. E1, E represent over here is elimination. Okay,
Mm-hmm.
yeah. So E1 mechanism is proceed through the intermediate, which is carbocation. Okay, so even proceed with carbocation and always getting more substituted alkene, or we can say more substituted product. Okay, while in case of E2 there is not any sort of rearrangement possible, so in this case we can say less substituted or more substituted, it depends upon the reagents. Okay, so in this case there is carbocation will form the direct product we are getting in this case. Okay, this is the E1 and E2 mechanism. Any doubt?
So what would so more substituted what does that oh okay, okay. No, I know what more substituted means. On you have something on either side of the double bond, right?
Yeah.
Okay. And then direct product.
Direct product means there is no any sort of rearrangement being possible. Okay. So this mechanism is with even type. Okay. Even mechanism. So what is even mechanism? In even mechanism is a type of elimination mechanism. Okay, that proceed with the help of carbocation formation. So there is a possibility of rearrangement. Okay, so see, there is a lot of reactions given in your PDF. So we discussed each reaction, and each reaction having some different mechanism. So we'll proceed each mechanism in that particular reaction only. Okay,
Okay.
so you don't need to like go with a reaction mechanism in detail firstly. Then okay, so we can proceed all the mechanism in this PDF. Do you understand even
Okay.
mechanism? What is even mechanism? What is the major characteristics of even mechanism? Tell me. E stands
E1
for
elimination.
elimination. Great. Then,
Unimolecular.
yeah, great. And
Um, you get a substituted
substituted.
carbon.
Yeah, that is important. Substituted product we are getting. And carbocation rearrangement will also be possible in this case. Okay.
Yeah.
Okay. Great.
Wait, sorry, I have one more question. So I
Yeah.
think did you mean to write 1,6 alkyl shift or 1,2? Because didn't we are we're working with
Yeah,
one and
yeah,
six.
yeah. We can 1 comma 2 can, right. I'm just representing these carbon with so these carbon 1 to 6 is the number of carbon. Okay.
Yeah.
And 1 to alkyl shift means the alkyl group shifts to the adjacent carbon. Like let's suppose if
Okay.
there is first and second. Okay, so the alkyl shifts is possible only on the nearby or adjacent carbon.
I see. Okay, so this is only when you're referring to alkyl by itself.
Yeah.
Okay. Yeah, the reason I asked is because like the way you numbered it, I was just like unsure. Like, if
Mm-hmm.
I understand now. Understand now.
Great, great. Okay, so this is the first reaction. Do you want to note down or take screenshot anything?
I was able to note it down, yeah.
Okay.
You can continue, ma'am.
Okay, okay. Okay. So the next reaction will be uh this one. This is the A1 I discussed question number here. Okay, so let's start with B. Okay, so this is the B part. Sorry, this is the carbon. Okay, and here is OH, and this will proceed in the presence of SOCl2 and pyridine. Okay, this is the reaction. Now, you tell me what is a pyridine?
What's a pyridine? It's a six. Does it have purine has like the A, hold on.
Pyridine.
Pyridine. G
Hmm.
and T. No, G and C, right?
Hmm?
Sorry, I'm thinking about in biology, in like the DNA.
No, okay, okay. Guanine and cytosine you are thinking about.
Mhm.
No, no, no. That
Oh,
that is in biology. So in this case, the pyridine is this one.
six-membered ring
Yeah, six
with the,
membered with
oh,
a
okay.
nitrogen. Okay, this is the pyridine. So what pyridine will do? Pyridine will act as a base. Okay, this is the reaction. So see, this is a sort of a reaction which you need to know. Okay. Firstly, in this case, SN2 mechanism will proceed. SN2 mechanism. What is SN2 mechanism? Tell me.
It's a, I think in this one, there's no
Yeah.
carbocation, right?
Yes, no intermediate.
But it's the substitution. React substitution, like S1 is the unimolecular
Yeah.
substitution. This one is
Yes.
biomolecular
Yes.
substitution.
What
Yeah.
does mean by biomolecular over here?
Means the reaction occurs in two steps.
Yeah. Great. So this reaction will proceed in two steps. Then no intermediate, only transition state will generate. But there is one more most important thing, that is inversion.
Okay.
Inversion is
Walden. I remember you told me Walden inversion, right?
yeah, Walden inversion. Inversion is the most important thing over here. So how we invert the product? So in this case, there is a SOCl2 we are having. Yes or no? So
Mm-hmm.
SOCl2 will donate a Cl. Okay. And now you tell me in SN2 reaction, I have Cl and I have this reactant. So what reaction will happen? Think about this.
Mm, acidic or acid base reaction or a reduction, oxidation reduction.
No, no, like if in substitution reaction, what is substitution meaning?
Substitution means that you're attaching another group to a carbon.
Yeah.
Yeah.
So now in this reaction, At which position the chlorine will attach?
The chlorine,
Yeah,
it's going to attach at a chiral carbon.
at absolutely at a chiral carbon. This one can I say?
Mm-hmm.
Yeah. So I'm also writing there that in this reaction the inversion will proceed. So what does that meaning of inversion? Inversion means the product which I'm getting is change the configuration by R to S or by S to R. Hmm? Isn't it?
Yeah.
Yeah. So what will be the product in this case? Is there any sort of rearrangement possible in SN2 case? Hmm?
Rearrangement for SN2. Uh, I don't, if rearrangement usually happens when there's a carbocation, right?
Yeah, yeah. So in this case, no rearrangement. So this is in this case we need a inversion only. So what does meaning by inversion? Inversion means a Cl will comes. Yes or no?
Mm-hmm.
Yeah. So a Cl will come and Cl comes at which position? At dash position. We attach a Cl. This is the reaction in this case. In this case, this is substitution reaction. So we need to substitute this OH group. Yes or no? And we
Mm-hmm.
are having SOCl2. So SOCl2 is a thionyl chloride and there is a pyridine. So thionyl chloride used to donate a chlorine group. Okay, so now this chlorine is going to substitute this OH group. So how this will attack? This will attack at this side, at this carbon, at this chiral carbon, and the OH will removed out. Okay, this is a simple reaction. Now in this case we are having OH on the wedge side. Yes or no?
Mm-hmm.
Yes. In reactant case, we are having OH at wedge side. So we need to invert this product. Invert, why inversion? Because this is a type of SN2 reaction mechanism. So we needs to
Mm-hmm.
invert this reaction. To invert this reaction, we are getting chlorine at the opposite direction where the OH is attached. Okay. So let's suppose if OH is on the wedge direction, so chlorine will substitute that OH from the dash direction. Okay, because it is a backside attack na. So chlorine
Mm-hmm.
attack from the backside and come to the dash, like the dash position. Okay, let's suppose say as this reaction, I am giving you one more reaction. Let's suppose this is the reaction OH. Okay, now in this case I told you that generate a mechanism pyridine here. So what will be the product in this case, tell me?
Um, goes from R to S and then S to R, right? So, I mean
Basic
the chlor. Hmm?
Basically the product will inverse.
Mm-hmm.
So in this case OH on the wedge, which side, dash or wedge?
This OH is on the dash side, so
So
that
chlorine
means,
will attach to
yeah,
wedge.
well, wedge. Okay.
Okay, understood how this reaction will proceed.
Yeah, but this is a more simple example, right? In other cases, it might not be as easy to tell like how it switches.
Yes, yes. There is after the first question there is a second question also. So in case of second question there is also assent to mechanism, but that assent to mechanism is in the cyclohexane form. Do you remember when we discussed stereochemistry?
Mm-hmm. Yeah.
Stereochemistry, there is the cyclohexane part. So
Mm-hmm.
I told you that whenever there is a reaction of cyclohexane will come, we need to generate a chair conformation for that particular. Yes or no? Do you remember that?
Mm-hmm.
Yes.
Yeah.
So in case of chair conformation, we are getting a little bit more tough as related to these questions. But this is the overall what is SN2 mechanism. Okay. In this case, you need to know that how this reaction will proceed.
Okay.
Understood.
Mm-hmm.
Great. So now the third part. So what is the third question?
Um, the third question.
C1.
Oh, I don't think I can see it. Sorry, do you want me to like look at my reference
No,
or
no, no, I'm
oh,
right here. This is the C OH POCl3, POCl3, and in presence of pyridine again. What is POCl3?
PO, that means phosphorus, oxygen,
Hmm?
and then chlorine. So phosphochlorine? No, oxyphosphochlorine.
Do you know what is phosgene? Phosgene
Hmm?
gas? Phosgene gas. Do you know about that?
No, I don't.
Okay.
Yeah, I don't think I've ever heard of that.
Okay, no issue, no issue. So, when this is the same reaction we discussed earlier, that is A reaction. Do you remember? The same reactant in A
Mm-hmm.
case we discussed. But in this case, there is we are having POCl3 with pyridine.
Mm-hmm.
So POCl3 pyridine, whenever come, that means this is a E2 type mechanism. Which type? E2 type.
E2. Mm-hmm.
What is the difference in between E1 and E2?
For E1, it will be more substituted,
Yeah.
whereas for E2
Hmm.
or E1, I think there is a possibility of carbocation rearrangement and then substitution. And then for E2, it's just like direct product.
E2 is direct product. That's the thing.
Hmm.
So now in this case, we are having OH and POCl3. So how this E2 mechanism will proceed?
Um,
This
Hold
is
on,
a
let me just
E2.
work.
E2 means elimination. So what we needs to eliminate?
Oh, sorry, I was just writing the reaction down, like the
Okay.
reagents and everything. Okay. I'm done writing it down. E2, so what's gonna happen is the chlorine. What's
Yeah.
the bottom? Oh, pyrimidine, right?
Yeah. Pyridine.
Pyridine. Okay. So
Yeah.
the top, the chlorine will attach to the carbon that has the OH function or hydroxyl group, right?
Hmm. I
So
didn't.
like the chlorine, it'll attach to this carbon, right?
Chlorine attached with which carbon?
Or sorry, this chlorine, right? Is that what we're?
This chlorine?
Yeah, didn't we do that before? Like, or no?
That is SOCl2. That is a
Oh,
substitution reaction. There is a
that's a
difference in
substitute.
between substitution and elimination.
Oh, sorry. I was confusing them together. Yeah,
Mhm.
my bad. So in this case, it's gonna be direct product. So
Yeah. In this case, the product, direct product we
yeah.
are getting, and this is the elimination reaction. So what will be the
Mhm.
product?
Elimination, you either get a double bond, right? Or is it a double bond?
Mm-hmm. Yes.
Alkene, right? So it's not gonna be on the one that's more substituted. It's gonna be on the one that's less substituted. The carbon, right? So like, can I edit? There's like an way to annotate or something. Like, not like on this carbon, right? Or is that more substituted? Like, would the double bond be here?
I do you writing anything on this?
Hmm?
Do you writing anything on this OneNote?
Oh yeah, yeah, yeah. I drew that. I annotated on there. Sorry.
That is not visible to me.
Oh really?
Yeah.
Are you on Zoom?
Yes.
You can't see when I draw this?
No.
Oh wow. That's interesting. You basically like you know the carbon that has those two methyl groups? It's
Yeah.
the carbon below that, right? That
Okay.
it would
This one.
attach to.
This one.
Yes, yes.
Okay. So what we needs to do?
So the double bond would be there, like between.
Okay, like here,
Yeah.
like this.
Mm-hmm.
Now see this again.
Oh wait, no, that's more substituted. No, the other side of the OH group, or the carbon, like on the other side, not this side.
On this side. Here.
No, 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 no.
Here.
No, no. I wish I could show it. Like,
Here.
can you not see here? Oh, yeah, 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 there.
Okay. So like this one.
Yeah,
Great. So why not this one? Hmm?
because it's more substituted.
More substituted only?
I know there's, but for E1 there's a carbocation, right?
Yeah.
For E2 there's none, so.
Yeah. Yes. So in this case, we are getting direct product. So if I will form this one, this okay. So if there is two possibility, this one and this one. Okay. So if I generate this carbocation, so in this case, see this carbon. How many bond this carbon having now in this case?
One, two. Oh, it's overfilling the octet, right?
Yes. So there is five bonds. So that's why this is not possible. Only this will be the
Mm-hmm.
product.
Yeah,
Okay.
yeah.
So you needs to remember that if there is a POCl3 in presence of pyridine presence, okay. So what sort of product will form in that case?
Can you say that again?
If there is POCl3, okay, that is phosphorus oxygen trichloride in the presence of pyridine, so in that case E2 type of mechanism will form. Okay.
Mm-hmm.
What is E2? E2 is a direct substituted product we are getting. Okay.
Mm-hmm.
Yes. If there is any possibility to gain more substituted product, then in that case it will happen with that part. Okay. But in this case, there is only one possibility. Okay.
Okay.
Okay. So now let's
Wait,
move. Yeah.
hold on. Let me just write this down.
Okay. Okay.
Copy it down. Okay, so it's not just that it's like more the first structure is more
It's wrong.
substituted, I guess, but it's like it's not just like that it's
No,
not.
no, it's
Oh.
not possible. This is not
Oh,
possible
okay, okay,
structure.
not possible.
Yeah.
Okay, so the logic that I had was wrong then. So I thought it was more, but I think I overlooked the fact that the octet was overfilled, so that wouldn't work.
Yes, yes. Let's suppose I'll write one more question to you, okay? Then tell me what will be the product in that case. So this is the product over here, and now you need to. I'm writing the same reaction, but you need to tell me what will be the product in that case. That is also from E2 mechanism, okay?
Mm-hmm.
Let's suppose here is OH, and again POCl3 in pyridine. So now you tell me what will be the product.
What will be the product?
Yeah.
Sorry, excuse me. And this is for E1 or E2?
Hmm?
E2?
Yeah. E2.
Okay. Can you not see my writing at all? Hold on.
No.
No, nothing?
No. Wait, I'm sharing my screen again. Then let's see. Now let's try.
Um, okay.
Okay, this is the.
Okay, can you see?
No. Okay, so you can tell me directly that which will be the product. Okay, I'm just
So
right.
strange. Okay.
Is there only there is two possibility. If there is any one possibility more, then you tell me first.
Um, okay. You want me to tell you like A or B, right?
Yeah.
Okay. For E2, right?
Yes.
For E2 it would be direct. Oh, it would be B for the second one.
B.
Mm-hmm.
Why not A?
Because it's more substitutive.
So, in the case of E2, why we are not giving substituted product? Is there any rule over there? Do I write anything over here?
Well, I think what you told me
So direct
before.
product doesn't mean that the product is not more substituted. If the product is
Oh,
more substituted, then we will prefer that. More substituted product will be preferred.
oh, okay. I think I misunderstood the meaning of direct product.
Yeah.
I thought it meant like no
Yes.
substitution. I mean,
No.
there has to be some
If
substitution, right? Yeah.
yes, like it depends. If there is more substitution will possible, then we go with that. That is like
Mhm.
preferable. But in case of carbocation, we can proceed with rearrangement also. The major difference in between E1 and E2 is that rearrangement. Okay, the product is always we needed more substituted in both E1 and E2. Okay, but in case of E2, there is no rearrangement will possible, so that's why we gave direct product. Do you understand now?
Mm-hmm.
Okay, so now tell me in between A and B, which is more preferable?
Um, A and B, I think. So then A, yeah.
Yeah. So A is more preferable as compared to B. Okay. So more substituted will be more preferred product always. So that is Set-Jeff rule. Set-Jeff rule. Set-Jeff rule describe that always more substituted, more substituted more substituted carbon, or we can say alkene preferable. Okay. Now you tell me the D one. First, you tell me what sort of functional group in the D.
Functional group epoxide.
Yes, epoxide. And HBr only written over here.
Mm-hmm.
So if there is HBr, that means this HBr will break into H positive plus Br negative. Yes or no?
Mm-hmm.
Okay. So H positive means the reaction is in which medium? Hmm?
Acidic.
Acidic medium. Whenever
Mm-hmm.
in a reaction there is a acidic medium, then there will be protonation will happen. Okay,
Mm-hmm.
always. What is protonation?
Addition of hydrogen.
Yeah. So how protonation on epoxide will form? See, there is a lone pair. These lone pair attack on H positive.
Mm-hmm.
Okay. Then it will convert into this O hydrogen over here, and this is the positive part. And, is this okay? Done. Any doubt up to now?
Um, Hold on.
Hmm.
Wait, so I have a question. So for E2, so if it's okay, so the main determining factor, if both E1 and E2 can be substituted more, the main differentiating factor between them is that E1 has something on both sides of the double bond as a carbon, or sorry, methyl group.
No. See, like, do you want to ask me like how we identify that the given reaction is even and given is even or E2? What sort of reaction? Hmm? Do you want that?
Yeah, like based on the product, yeah.
Okay. Based on the product. So based on the product, we are not able to identify that given is even or E2.
Okay.
Based, okay, based on the reactant or based on the reagents which we are using. Okay, so see, majorly in case of acidic medium,
Mhm.
we are proceed
Yeah.
with even. Okay,
Mm-hmm.
and let's suppose there is POCl3 in presence of pyridine. Majorly in presence of pyridine, we are proceed with E2 mechanism. Okay, and if there is a higher temperature, then we proceed with even. So these are some rules when we proceed with even or when we proceed to E2. Okay.
Wait, sorry, can you? I'm gonna write them down. What is it? What did you write? Sorry, what did you write? H plus is E2?
H plus means acidic medium.
Acidic medium. Okay. And then what did you write at the bottom, ma'am? Like, what did you write
After
for
acidic medium, there is a POCl3.
PSA? Yeah, below that.
Below that, this is the representation. This triangle represent a higher temperature, high temperature. Whenever we heat any reaction,
Oh, I see. What is POCl3 again? What does that mean? What is that? What is that again? What reagent?
POCl3 is phosphorus oxygen trichloride.
Wait, sorry, can you write that? Phosphorus,
Phosphorus, oxygen, trichloride.
phosphorus, oxygen, trichloride. Okay.
Yeah.
And this is only used in E2.
Yes.
And then P1 is what, pyridine?
Yeah. Py.
Pyridine. Okay. So this is only E2 specifically.
Yeah. Yeah.
And
And
then
acidic.
addition, I'm sorry?
Huh? In acidic medium, there is even. And
Okay.
on a higher temperature, then that will also even at higher temperature.
Is it so for E1, the hydrogen, does that help it become more substituted?
Yeah.
Oh,
Hydrogen.
that's why.
Yeah, hydrogen used to convert a carbon into carbocation. So whenever carbocation will form, the reaction will proceed with the even mechanism.
Okay. Oh, carbocation, right.
Yeah.
Yeah.
Hmm.
Mm-hmm.
Okay. So this is but in this case, this is a normal ring opening reaction. This is okay. So in this case, see, there is H positive and Br. So the first step is protonation will take place. Okay, protonation. Then in next step, what is the left reagent in this case now? Mm-hmm.
The left reagent,
Yeah.
hold on. Is it an ether?
No,
Oh, no, no, that's
Br
really
na.
different. I'm sorry.
Yeah, Br negative.
Oh, oh, BR. Sorry, sorry. I don't know what you were asking me.
Okay, so Br is left here. Now the Br needs to attack. Attack at
Okay.
there is two possibility at this carbon and at this carbon. Okay, there is two possibility. So now you tell me at which position the Br will attack.
Mm, coordination. The BR will attack on the more substituted side.
That's great. How?
By the ring opening.
Yeah. So whenever there is a acidic medium, okay,
Mm-hmm.
B, yeah, and here will be the OH. Okay, okay, sorry. So Br will come with the dash part, and OH will come from the dash part. Okay. Why I'm putting Br on this part? Hmm?
Because this is for E1, right? So E1 is gonna be more
No,
it's,
no,
I
no,
mean,
no. This is not. No, this is not any type of reaction, even or
oh,
anything.
oh,
Yeah.
okay.
Now you tell me. Yeah.
Why did we put it on that side?
Okay. So see, this is a ring opening reaction.
Mm-hmm.
A ring opening reaction. Ring opening reaction of epoxy. Okay. So there is two possibility. The first is in acidic medium, and the
Mm-hmm.
second possibility is remaining all the reaction. Okay. So whenever any reaction is in acidic medium, then we proceed that nucleophile attack at more substituted site. At more substituted site. Okay. while in this case nucleophile attack at less substituted site. So see, from the reactant and reagent. So what is reactant over here? Reactant is epoxide. Okay.
Mm-hmm.
And what is reagent? The reagent is HBr. Now from HBr we know that HBr is break the down into H positive and Br negative. Okay.
Mm-hmm.
H positive is in the reagent or reactant part. H positive means the reaction is in
Mm-hmm.
acidic. So
Mm-hmm.
if there is ring opening reaction will proceed in acidic medium.
Mm-hmm.
So in that case, nucleophile attack at more substituted site. Okay, so protonation will take place, and the epoxide will gets protonated. Okay, now the nucleophile in this case is the bromine. Now the thing come that bromine attack at which position? At the more substituted side or less substituted side? So from the ring opening reactions in acidic medium, we proceed the bromine to the more substituted side. Okay. Any doubt up to now?
Yeah, no, not really, but
Hmm.
I I understand, like I understood why you would have put it on the substituted because then the ring would need to open.
Yeah.
So like how it would attach. Yeah, that makes more
Hmm.
sense. That makes sense.
Hmm. Then the next part that why I'll attach the bromine on
Mhm.
dash side. Why not on wedge side? That is the question now. Now you tell me why I
Does
have
it
to.
have to do with chirality?
Yeah, chirality, but like why on the dash? Why not on wedge direction?
Not on wedge because
Because OH is already
yeah.
present on the wedge side.
Yeah.
Okay, so now the
Yeah.
bromine needs to attack from the backside.
Mm-hmm.
Okay, so after backside attack, the bromine will get dash direction, and OH will getting wedge.
Mm-hmm.
Okay, any doubt up to now?
Mm, okay. I have a question.
Hmm.
Does absolute configuration matter in these cases that we went over? Remember?
No, no.
No.
They in exams, examiner can ask you that what is the configuration. So in that case, you need to give R and S. But there is not any sort of perfect configuration. We can say that let's suppose if the reactant is R, then the product will S. So there is not any sort of rules regarding them. Okay, there is no rule in this case.
Okay.
Okay, now the E part will come. Okay, so
Mm-hmm.
any doubt in this?
Wait, in this case, there's no carbocation, right? Or no, there was. There was.
No, there is
Right?
no.
Oh, no, there's no carbocation.
Carbocation means the positive on carbon. There is no carbon.
Carbon, yeah. Yeah, there's no, yeah. Okay.
Okay, then the next is
Mm-hmm.
E. Okay, so in case of E, OH again we are
Mm-hmm.
having acidic medium H2SO4. Now you tell me what will be the product, and now you proceed this reaction. This is very easy.
Yeah, so that one is gonna be if it's an acidic medium. This is for E1, E2, right?
Hmm.
If it's an acidic medium, then it's gonna be what is it called? E1.
Yeah, great.
Okay, so then what's gonna happen is the hydrogen
So now you are
will,
able to understand like what sort of reaction in this. By
yeah, now I'm able to see.
great. Now you tell me what will be the product.
Yeah, so the hydrogen, so the H2SO4, you're gonna get H plus and SO4 minus, right?
Yeah.
Okay.
Then.
So the yeah, so then what's gonna happen is it's going to the O will the OH react with the H plus?
Mm-hmm. Great. Then.
So the OH reacts with the H plus, then that means there's a molecule of water that's produced.
Great. So this H, this will converting into H plus and SO4 2 minus these ions. Okay.
Yeah, two
Now
minus.
this, yeah, this lone pair of O will get this hydrogen and it will converting into OH2 positive.
Mm-hmm.
Then this OH2 positive will remove with the help of dehydration. Okay.
Mm-hmm.
And is there any carbocation will generate over here?
Yes.
Yes. Then now you
Then
tell me.
what's gonna mm-hmm. So then E1. So then that means is there gonna be a hydride shift?
Very good. 1 2 hydride shift. Good.
I was just
1 2.
thinking because you need a double bond, right? So I was like thinking, okay, what would you do?
Yeah.
Yeah.
So is there any possibility of hydrogen? So there is a hydrogen and here hydride shift. Okay. Then
Mhm. Carbocation rearrangement is done, right?
done. Yeah. Now
Okay.
the elimination will proceed. So there is this one hydrogen,
Mm-hmm.
this hydrogen, and this hydrogen. Okay. So there
Mm-hmm.
is three hydrogen. So there is three probability to form alkene. And this is the first probability.
Mm-hmm.
If I remove this hydrogen, then if I remove this one, so this is the second probability. If I remove this hydrogen third, so that will be the third probability. Any doubt in this?
Mm, oh, it's always gonna be next to the carbocation. Okay, yeah. But let me just
Okay.
write this down.
Now you tell me which is major product in this case.
Which is major product?
Yeah.
Major product will be more substitute.
Yeah.
It's gonna be more substituted, right?
Yes. So which is more substituted?
Um, I think the one in orange
Orange one.
or one,
So how
two.
we identify more substituted?
Uh, I mean, if you're looking at where the carbocation is, right? Let me see how many groups there are around something, right? So,
More substituted means the maximum number of alpha hydrogen.
oh, alpha
Okay. So
hydrogen.
how we identify alpha hydrogen, number of alpha hydrogen? Do you know?
I think alpha hydrogen is what comes off of the carbon, right, already.
Yeah. Let's suppose this is alkene. So these
Mm-hmm.
are two carbons. Okay. Now
Mm-hmm.
the nearby carbon. Let's suppose these one,
Mm-hmm.
two, and three. So these are alpha carbon, and now the number of hydrogen attached to them is alpha hydrogens. So in this case, there is total 6 alpha hydrogen. Okay. And
Mm-hmm.
now let's move to this one. So these are the alpha carbons. Firstly, the carbons which directly attached to alkene, those are alpha carbons. And the hydrogens over there, one, two, three, and one and two, and one and two. So how many alpha hydrogens?
How many?
Hmm?
Two, four, seven?
Yeah, 7 alpha hydrogen. And in this case, let's suppose 1 2 1 2 1 2. So there is 6 alpha hydrogen. Okay.
Oh, I thought the double bond had something to do with the substitution too. No, right?
Hmm.
Like I thought
How?
that when you were looking at substitute, like how much substituted, I thought the double bond also had a role to play in that, but it's just the
Yeah.
hydrogens, right?
Double, so alpha hydrogen will check with respect to double bond, na? So if there is no double bond, then
Mhm.
how will calculate alpha hydrogens?
What is so what's the difference between alpha and beta? I've also heard of beta hydrogen.
Yeah, alpha means, let's suppose this is the alkene. Okay, this is alkene, this one.
Mm-hmm.
And the first carbon which attached with the alkene is alpha carbon. Okay, this is the beta carbon, this is the gamma, and this is delta. Okay, so after 4, all the parts are considered as delta. So alpha carbon, that first carbon which attached with alkene. So the hydrogen which attached to the alpha carbon, that is alpha hydrogen. Hydrogen which attached to the beta carbon, those are beta hydrogens. Okay, like that. Hmm?
Okay, let me just write this down. I don't want to just
Okay.
take a screenshot. I want to just make sure I have it down.
Yeah. Okay. So in this case, the major product is this one.
Mhm. Okay. Wait, so if you don't have a double bond, then the hydrogens that you're looking at, they have no value?
Mm, like it depends, na? It depends. If there is no double
Okay.
bond, it can be any functional group over there. So with respect to functional group, we can identify. Let's suppose if there is no double bond, if I am having a carbonyl group. Okay, let's suppose I'm having a carbonyl group. This one, double bond O. Okay, so in this double bond O, this is alpha, this is beta, this
Mhm.
is gamma. Okay, so we check with respect to these alpha groups. It depends on the reaction.
What does substituted actually mean? Like, I hope this doesn't come across as a really stupid question, but what does substituted really mean? If that makes sense.
Substituted means more substituted means surrounded by more peoples, more groups.
Okay.
Okay, number of groups.
Okay, so in this case, because there's no functional group, we would just look at the alpha hydrogen, right?
Yeah.
But if there's a functional group, we would prioritize that first or the alpha hydrogen.
Hmm?
Like if there's functional group, right, already there, we would prioritize that over the
Yeah.
alpha hydrogen. Okay.
No.
So then,
Like it depends upon the reaction. It depends upon the reaction.
okay.
Okay.
Like for acidic medium, like let's say for example.
For acidic medium, what sort of reactant you are taking?
Mm,
In your mind, what are you thinking? Well, like what reactant you are using?
okay. Oh, I didn't think that much in detail or that far actually. Maybe I should have thought before asking because it's kind of a vague question, I guess, what I'm asking.
Okay.
It's like too broad or vague, I think I'm realizing because it really just depends, right, on the
Yeah, it
can't
depends upon
generalize.
reactants. Hmm.
You can't generalize or make a broad statement
Yeah, in organic reaction, you can't.
because there's like millions of reagents, millions of react.
And
Yeah.
each reagent or each reactant have different properties. They can react with any
Mhm.
other. Okay, so if they react with a single reactant or a single reagent, then we can generalize some rule
Mm,
about it. Yeah.
like for example here, right? So in E1, the reactant had a functional group hydroxyl, right? So in this case,
Mm.
you're not going to end up with that functional group anymore. So you can kind of guess it's going to like the substitution will be based on the hydrogen, if that makes
Yeah.
sense.
Yes.
Okay. Because you also have a hydride shift, so like
Yes.
if all okay, yeah.
Mhm.
So the hydride shift itself would kind of tell you that you need to look for that, right?
Yeah.
That. Mhm. What about the methyl group though? Like, you know how there's a methyl group sticking out? We're not
Mhm.
those that group by itself is not important, right?
Yeah, on like if there is no any methyl or alkyl shift will be there. So in that case, the methyl group is not as much important.
Oh, okay. That is like kind of a pattern then. So
Yeah.
hydride shift means hydrogen is more important, alkyl shift means alkyl is more important
Yeah,
in the
yeah, yes, for sure. If hydrogen shift will be there,
Oh.
so hydrogen will no, no, no. Like okay, okay, okay. So wait. You are thinking that if there is hydrogen shift, so that's why we are calculating their alpha hydrogen. No, no,
Yeah,
that
yeah.
no, no.
Okay,
We
okay.
will calculate alpha hydrogen always if there is hydride shift, if there is a methyl shift, any sort of shifts will be. Okay, we will calculate alpha hydrogens only to identify that the given alkene is more substituted or not.
Okay.
Okay, yeah,
Mm-hmm. Okay, that's clear.
okay.
Sorry if
Now,
I like confused you a lot about what I was asking.
no, no, no.
Okay.
FG. Okay, so next is F. F is again a epoxide, and here then there's first KCl, then the second is H3O positive, that is dilute. Okay, see now, up to now we discussed one more thing, that is a POCl3 and pyridine. Okay, this one. So,
Yes.
do I mention any sort of numbers over there in POCl3 and pyridine like this one,
Mm-hmm.
as I mentioned in case? No. So, what is the difference in between them?
Sorry, give me 1 second. I'm gonna charge my computer like charger.
Okay.
Can you repeat your question, please? Sorry.
Like here, I'm representing one and two. But before that, there is
Mhm.
a reaction in which I represent like the reaction with POCl3 and pyridine. So in that case, I didn't mention any sort of numbers. So what is the
Mhm.
difference in between them? Like, do I need to mention numbers in each reaction or not? What is the difference?
I think I remember I asked you this question myself, and I think you said that it doesn't really matter. Oh, I see.
You asked me that if there is some reagents which is above the arrow and below the
Hmm.
arrow.
Yeah, yeah, yeah.
You asked me that. Yeah, but the difference in between these, like the first and two numbers mentioned. So if there is any number mentioned, in that means that let's suppose this is a epoxide we are taking, and in the first
Mhm.
step we need to add KCN only, that is potassium cyanide. Potassium cyanide, we need to react that potassium cyanide with the epoxide firstly. That is the first step. And after completing the first step, I am adding the second step, that is adding dilute H3O positive into the reagent. Okay, that is the meaning why we need first and second. So we need to add separate both of them. But before that, I discussed this one, POCl3 and pyridine. So in this case, I am taking the reactant and I'll put the POCl3 and pyridine in the same jar as I put in this reactant. Okay, so I
Mhm.
add both these reagents in the same time. While in case of this one, I need to react firstly with KCN, then with H3O positive and dilute. Sorry, KCN and dilute hydronium ion. Okay.
Okay, so what the difference would be? So this is not an acidic medium, right?
No,
Okay, so this is potassium cyanide for number one.
but yes.
Potassium cyanide. So I remember you told me that cyanide is a very reactive structure because of the electron delocalization. Repulsion.
Yeah.
Cyanide. Like there's this huge repulsion between carbon and nitrogen or something like
Hmm.
that. Is that what you told me? No.
Cyanide
Maybe
is
that.
very low only. Yeah.
Oh, yeah. Maybe you're talking about something else with cyanide. This is
Yeah.
cyanide alone, right?
Yeah. Yeah. Yes.
Okay, so and then so I think the H3O plus is it like is gonna dilute, right? So then it's gonna make the effect of cyanide less. No, that
No.
doesn't. I don't think that
No.
makes sense.
No. No.
It,
Because see, in this case, firstly we react cyanide with the epoxide. Then after completing
yeah.
this reaction, we add H3O positive and dilute medium.
Yes. Oh, okay. Yeah. So, oh, it's just telling you the order then.
Yeah. Yes.
Okay, it's just the order. Sorry, I don't know
Yeah.
what I was saying. Like, I was just speculating something random.
This is epoxide, and now the reaction is
Yeah.
ring opening reaction.
Okay.
Okay. In ring opening reaction, I told you that there is only two possibility. Yes or no?
Yeah.
There is
Mm-hmm.
only two possibility. The first is if the reaction is in acidic medium, and the second is the reaction is not in acidic medium.
Mm-hmm.
So to tell me, is this reaction is in acidic medium or not?
No.
No. So the first step means there is no acidic medium. So if
Mm-hmm.
there is no acidic medium, then the nucleophile. In case of KCN, what is the nucleophile? Cn minus is nucleophile.
Mm-hmm.
So Cn minus
Yes.
attach at which side?
It's gonna attach where
More
the more
substituted or less?
substituted. Yeah, more
More or
substituted.
less? Are you sure?
Mm,
See, I'm writing here.
yeah, I think
I wrote here that if in ring opening reaction there is acidic medium, that means more substituted, and
oh,
remaining all, that means less substituted.
less substituted. Okay. Yeah.
So Cn minus attack at this carbon. Okay,
Yeah.
great. Then it will converting into uh, here is O minus and like this, and here Cn attached over there. Okay.
Mm-hmm.
Any doubt? Then dilute H3O positive will come. H3O positive is this structure. Okay, this is the structure of H3O positive. H3O, oxygen is having positive charge. So now this oxygen take this hydrogen, okay, and converting into OH. Here is cyanide and here is methyl. Okay. Any doubt in this reaction?
No.
No.
Oh, I can see why it adds to the less substituted side because if you were to add to the more substituted side, you would not have that H plus to then attach, right? Or sorry, like in the other case, like you know how you have HBr, right? So it attaches to H
Yeah.
plus first. You won't
Yeah.
you won't have another nucleophile to go and attack on the more substituted side, if that makes
Yes.
sense.
Yes.
For the ring
If
to
there
open.
if there is let's suppose I am using HCl over
Mm-hmm.
KCl. Okay, so in that case there is I have H. Okay, so
Mm-hmm.
if I am having H, then the reaction will proceed in acidic medium.
Mm-hmm.
Okay, so it will protonate
Mm-hmm.
and the nucleophile will attack on more substituted side. While in this case there is no any acidic medium in the starting of the reaction.
Mm-hmm.
Okay, that's why the reaction will proceed through less substituted part.
It would be more bulky.
Yeah.
on one side.
Mm-hmm.
That's why it would be more favorable because in the
Yeah.
other case, the protonation allows for that space
Yes.
late. And yeah, because it's all about stability, right? In chemistry, like you want to just go towards more favorable states.
Yes. In organic chemistry, how the product will stabilize, that's all we need to identify.
Okay.
Okay. Okay. Do you have any doubt? Anything up to now?
No.
No?
Wait, let me double check. I'm gonna say that and then I'm gonna have questions. Okay, wait. Let me try to summarize and clarify anything I what I
Mm-hmm.
understood. So we went through the worksheet, right? Organic reactions review. So like we went through examples with like the alkyl shift, hydride shift.
Yeah.
When you encounter a carbocation intermediate, which happens in
Mm-hmm.
E1,
Mm.
so it's gonna prefer the not necessarily or both E1 and E2 want more substituted because it's more stable, but E1 has the carbocation
Mm-hmm.
rearrangement.
Mm.
That's like the is that the only that's the main thing, right? Or let me see.
Or carbocation rearrangement?
Yeah, that's gonna form in the E1, right?
Mm-hmm.
So is that the main differentiating factor between E1 and E2 again?
Yes, yes,
So the carbocation is the defining factor?
yes.
Okay, yeah. Because when I asked you about this substitution, you mentioned like that's important regardless. Um, okay. And then we covered like different, so then there was one with like acidic medium, and then and then hydrolysis, and then we covered like something like sulfur chloride. So what is this called?
Yeah,
So
SOCl2 and POCl3.
what is SOCl2 again? What is it called?
Thionyl chloride, thionyl chloride.
Wait, can you like write that on the board, the spelling? Okay. Thionyl chloride. And this is mostly for E no, SN 2, right?
Yes, yes.
So thionyl chloride and then pyridine. This is for SN2.
Hmm.
And does the pyridine do anything?
Pyridine is used to donate its lone pair and destabilize the reagent or reactant in transition state. As we know that in SN2 there is a transition state will form. So
Mhm.
to stabilize that pyridine will help.
In transition, so stabilizes the reaction in transition state. I'm just writing that down. Donate to let's electrons. And then we covered E1 and E2. And then you mentioned, oh, I think another thing you mentioned about E1 and E2 is the overfilled octet, right?
Hmm.
Like if you have a structure in the product, the octet rule cannot be broken. I
Hmm.
think you mentioned that we covered ring opening with epoxide, protonation, and then POCl3, which is phosphorus oxygen trichloride, right?
Hmm.
Cross, and that happens in E2, and then acidic medium is only in E1. And the temperature increasing also indicates E1, right?
Yeah, high
Okay.
temperature.
Okay. And then for H plus nucleophile attacks at more substituted site, remaining will be at less substituted, right?
Sorry. At
For
it?
epoxide. Sorry, for like epoxide opening,
Mm-hmm.
the nucleophile will attack at the more substituted side, and then the remaining will
If
be less
the
substituted.
medium, if the medium is in acidic,
Oh,
acid
this
in
is for
acidic
acidic.
medium, yeah.
Oh, acidic. Okay.
Mm-hmm.
So the remaining that's not acidic will be less substituted.
Mm-hmm.
And then I think that's it. And then the alpha hydrogens can tell us about the substitution, right?
Mm-hmm.
I think that's all we covered. Okay, I think I'm good. I clarified. I think I clarified Everything, yeah.
Okay. Okay, so remaining part we will start with next class. Okay.
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 Bye,
And
ma'am.
your homework. Wait a second. I'll give you some questions. Okay. There
Okay.
is some questions. That is the on. Okay, so on page number 6,
Okay.
there is alkenes that is in bracket. There is continued. So in alkenes, there is the question B, C, and D. Okay,
Okay.
B, C, and D in alkenes. And okay, so you'll do that only.
B, C, and D?
Yeah,
Okay, and you want me to present my work next time, right? Next
yeah,
class. Okay. Because there's only 3 problems, so I can do it within a day. It's not like a lot, you know.
yeah.
Okay. Okay, thank you, ma'am. Thank you so much. Have a good
Okay,
rest of your day.
okay.
Okay, bye-bye. Thank you.
Bye.